Okay, then Michelle is number 1. Okay, Michelle is still drawing, and then let me ask for the second one. Okay, uh, so number 1 is going to be answered by Michelle, and then number 2 I would like to ask Clara Bella.
Teacher,
Yes,
is it or oh no, the shape is tetrahedral
tetrahedral. Yeah, and the
and
angle.
the angle is 109.5.
Yes, correct.
Um,
Then
okay.
number 2, Clara Bella.
Yes, teacher.
Yeah, Clara Bella, what is the shape of the molecule of the polyatomic ion of PCl 6 minus?
Wait, teacher.
Yes. Okay. So Clara Bella is still drawing. Number 3, I would like to ask to Bavia. And then number 4, like to ask to Natasha. And then number 5, Nathan. Nathan V. And then number 6, I'd like to ask to Ariela. And then number 7, Bryans.
Teacher,
Yes,
the bond the bond angle is 90 degree,
the bond angle is 90 degree. And then
and then the shape is octahedral.
octahedral. Yes, correct. So number this one is correct. And then next, how about Bavia?
Teacher, is the angle 109.5?
SO 4 109.5.
5.
What is the shape?
Tetrahedron?
Tetrahedron. Okay, tetrahedral or tetrahedron will be the same. Okay, yes, correct. And then number 4, Natasha.
Teacher, is it 3 bond pair and 1 lone pair?
3 bone pair and
1 lone pair.
1 lone pair. Okay. Now, what is the 3 bone pair and 1 lone pair? Hmm. What is the uh, angle?
107.
107. Are you sure? Okay. Let's we keep this one later on. Okay. Because 100 because NO3 nitrate is not. Nitrate is supposed to be trigonal planar. Okay. and then later I will discuss. Don't worry, Natasha. And then Nathan V.
Salutation.
Yes, Nathan V.
For this one, I will say that this might be a non-linear shape.
It is not linear. Yeah, correct. It is not
And
linear.
then one angle will be around 117 degrees. Around that.
117.
Yep.
Okay, what is the shape?
The shape will be like triangle like that, but with a small angle at the top and very big angle at the bottom. Triangle.
No, it is not triangle. It is a V shape.
T-shape. Okay,
Yeah,
sir.
V shaped. So it's a V shaped or pen.
Then
So yeah,
okay.
it is the V shape or pen. Okay, so it's V shape, and then now Ariela.
The shape is tetrahedral
Okay, tetra.
and the angle is 109,
Yes, correct. And then Brian.
109.5.
Yeah, yes, correct, Ariela. Brian.
I
Should
got
fight.
I got 3 bond pair
Yeah,
and 1 lone pair.
yeah. What is the angle?
So it's so it is 107 degrees
Mm-hmm.
and the shape is triagonal pyramidal.
Yeah, okay, correct. So Ariela, correct. This one correct. And O3 negative is difficult to draw. Don't worry, Natasha. I don't think you are the only one have problem. Okay, and then number 8. Number 8. Wait. Number 8. Let me unlock the meeting. Okay. Number 8 and 9. Number 8 and 9 is CH3 positive, and then number number 8 is CH3 positive, number 9 is CH3 negative. Okay. For number 8, let me ask to Felicia. What would be the yes?
It's 3 bond pairs and 0 lone pairs.
Yeah. So
Is it diagonal planar?
the angle is
120 degrees.
the shape.
Trigonal planar.
Yeah, correct. And then for the last number 9, I would like to ask to Vedika. Hello, Vedika.
Teacher,
Yeah. What is the uh, bond angle and shape of CH3 negative ion?
wait, teacher,
Yes.
just a minute. Teacher,
Yes, Vedika.
I am not sure, but is it 120 degrees?
100.
20 degrees.
20 degrees? No, it is not. No.
Okay, teacher, then I'm not sure then in that case.
Okay, it's the last number 9 is 107 degrees trigonal pyramidal. Why is it like that? I will show it to you. I will show to you how to make the bond. Okay, how to make the dot and cross diagram. I have prepared the discussion. This one. Let us discuss the question about VSEPR for polyatomic ions. I have provided with 9 questions of the polyatomic ions. In these polyatomic ions, you have to draw the structures and also to tell the number of bond pairs, number of lone pairs, the angle, and also the shape of the polyatomic ions. Okay, let's see from number 1. Number 1, there is PCl4 positive. How's the diagram of PCl4 positive? Let's see this one. Okay, so PCl4 positive, as we can see here, there are phosphorus. Phosphorus has 5 electrons in the outermost shell. This 1 electron from the phosphorus is moving out from the structure. That means the ion become positive because there is 1 electron gone. And then so all these will form 4 bond pairs and 0 lone pairs or no lone pairs, and then the shape is tetrahedral structure with 109 degree angle. Okay, as we can see here, there are 7 electrons around chlorine. So this is the correct diagram of how to display the dot and cross diagrams. There has to be 7 electrons around each chlorine, and there has to. Okay, Felicia or Vedika, could you hear the voice?
Yes, teacher.
Okay. Be 4 electrons around phosphorus. Why? Because 1 electron is lost. Now let's continue to number 2. Number 2 is PCl6 negative ion. Negative ion means gain an electron. Okay, so let's see number 2. Here, number 2, here, there are 6 chlorine. There are 6 chlorine, and then in each chlorine, there are 7 electrons. This is electron which is gained from outside. This become negative ion. Let's see here, 1 pair, 2, 3, 4, 5, 6. So there are 6 bond pairs and without any lone pair. So the size of the angle is 90 degree, and then the shape is octahedral. Okay, when we draw dot and cross diagram, it should be like this. Okay, do we need to show like the shape of octahedral is not required, because in I level they expect us to draw dot and cross diagram like this to show how many electrons are around chlorine, how many electrons around phosphorus. Now let's number 3. Number 3 is sulfate ion, SO2 minus 4. Okay, so we have to draw the diagram sulfate ion. Sulfate ion is like this one. Okay, so there are 2 double bonds between S and O, we know that double bond occurs because of overlapping of the s and p orbital of the same atoms. So these double bonds can be considered as a single bonds. So there are two electron gain. Which one? This one and this one. This one has one. Let's count the oxygen, the electron of oxygen here. There are 8. 1, 2, 3, 4, 5, 6, 7, 8. Over here also the same 8 electrons around oxygen. So it means there are 4 bond pairs and 0 lone pairs. So the angle is 109 degree, 109.5 degree, and tetrahedral shape of molecule. Next, number 4. Number 4 is a nitrate ion. Okay, let's see how's the diagram of nitrate ion. Nitrate ion we have to draw like this one. So there are 5 electrons around nitrogen, and then which one are the electrons? The process 1, 2, 3, 4, 5, and then this one will form a double bond to oxygen. This one a single bond, and there is an external electron. Now this one is dative covalent bond from the nitrogen to the oxygen. That makes the oxygen has 8 electrons, and then here the nitrogen has 8 electrons also. And then therefore the number of bond pairs, there are 3 bond pairs and no lone pairs. The angle is 120 and the shape is trigonal planar. Next, nitrate ion, NO2 negative. Let's see the diagram. The diagram has to be drawn dot and cross diagram. Let's see here number 5, and there is a double bond with the oxygen. Double bond can be considered as a single bond because there is an overlapping of s orbital and p orbital of the same 2 atoms. And then there is an N here, and there is a lone pair and there is a bond pair with the oxygen, and there is an external oxygen, external electron in the oxygen that makes the ion become negative. So in conclusion, there are 2 bond pairs and 1 lone pairs. Okay, so the angle is 119 degrees. The shape is V-shaped. Now let's continue to this one, ammonium ion. Ammonium ion, as we discussed yesterday, ammonium ion drawing is like this. This one is dative covalent bond. Why? Because hydrogen doesn't have electron. So the nitrogen make a dative covalent bond to the hydrogen that makes this one become 2 electron around hydrogen and 8 electron around nitrogen, and then this one carries positive charge. So in conclusion, there are 4 bond pairs and no lone pairs. So the shape is tetrahedral. The angle is 109.5 degrees. Next, sulfite, SO2-3. Let's see how the diagrams look like. The diagram looks like this one. So there is a double bond between S and O, and then there are 2 electrons from outside that make the electron of the oxygen become 8. This one 8 electrons, this one 8 electron, and there is a lone pair of the sulfur. That makes there are 3 bond pairs and 1 lone pair. So the shape is trigonal pyramidal with 107 degrees. And then there is a CH3 positive. CH3 positive, this one is the diagram will look like this one. Okay, so there are 3 bond pairs because the 1 electron of the carbon has moved out, has undergo ionization. This it lost electron, become positive. So there are 3 bond pairs and no lone pairs. The shape is triplanar with angle 120 degrees. So molecule and also polyatomic ions, they have shape and angles. But for the monoatomic ion does not have, and monoatomic molecule does not have. Example, monoatomic molecule is a noble gas like krypton, xenon, argon. There is no shape. And then the last question is CH3 negative. CH3 negative ions means it gains an electron. So it gains an electron here, means gain electron. So here there are 3 bond pairs and 1 lone pair. 3 bond pairs and 1 lone pair is trigonal pyramidal with 107 degrees. Okay, so these are the discussion of today's worksheet. We are doing it online. We are going to see each other again on the next day with. Okay, so so we already discussed the answer, and also I give the question on the Google Classroom just now for you to review, and then later I will put also the link of the recording of our WebEx on Google Classroom also. Is there any question until here?
May I ask?
It is okay.
For the one before NO3 minus, so there are like 3 double bonds.
Yes.
So we can say there are 3 bond pairs.
Yeah.
Thank you, teacher.
Yeah. So these are the polyatomic ion, and then now I would like to ask regarding this one. Okay. Regarding this one, let me share. Also will not take too long for us. Okay. Let's discuss quite not difficult this one. What is the structure of what is the bond angle of BeF2? Let me ask to Sherry. Sherry, what is the bond angle of BeF2, beryllium fluoride? Hello, Sherry. Okay. Yes, Sherry.
Yes,
What is the
180,
angle of BeF2?
180.
180. What is the shape of the molecule? Yes, Sherry.
Yes, teacher, linear.
Oh yeah. Okay. Thank you. And then now PCl5. PCl5. Let me ask to Hardy. Hello, Hardy. Hello, Hardy. Okay. Next, let me ask then. Oh yeah, Hardy is back. Hello, Hardy.
Yeah.
What is the bond angle of PCl5?
90 degree
90 degrees only.
and 120
Yes. So what is the shape of the molecule?
trigonal pyramidal.
Yes, trigonal bipyramidal. Okay, and then next tetrachloromethane CCl4. Then let me ask to Matthew.
Yes, hello.
Hello, Matthew. What is this one?
The bond angle is 109.5.
100 CCl4.
9.5.
Yes. And what is the shape?
Tetrahedral.
Yeah, correct. And then number 5. Number 5, let me ask to Eric.
90 degrees.
90 degrees. What is the
Octahedral.
shape?
Octahedral.
Yeah, correct. And then for the last question, sulfur trioxide. What is the bond angle of sulfur trioxide? Let me ask to Timothy. Hello, Timothy.
Hello, teacher.
Yes, Timothy. What is the bond angle of sulfur trioxide?
The bonding is uh, bonding is the angle, teacher, like the angle.
Yeah. What is the bond angle?
120 degrees.
Yeah. And then the shape of the molecule?
Trigonal planar.
Yeah, correct. So all this, you could answer everything but well. Okay. So there is no problem with the VSEPR anymore. I consider there is no problem with VSEPR. Now we are going to have the discussion about intermolecular forces. Okay, intermolecular forces like that. I have my that I give the presentation on. Do not remember on few days ago. Few days ago about the intermolecular forces. Okay, let me show this one. Let me find the presentation about intermolecular forces. Yes. Okay, about intermolecular forces. Let me ask from some of you. Let me ask from some of you regarding intermolecular forces. Yeah, intermolecular forces. Okay, this one regarding intermolecular forces. Now let me ask to some of your friend. Let me ask from Patrix. Hello, Patrix.
Yes, teacher.
How many intermolecular forces are there?
2,
Yes. Yes, Patrix.
2,
2. What are they?
oh wait,
What are the types of intermolecular forces?
uh, is it like,
You still remember?
is it like a
Yes, Patrix.
hydrogen bond? Is it like the
Hydrogen,
hydrogen bond and then, teacher?
hydrogen bond, and then
Uh,
and then
I forget, teacher.
okay. There are okay. Forget. Let me ask to Vanessa. Vanessa, do you still remember how many? Do you still remember the types of intermolecular forces?
Are there 3 of them?
Yeah. What are they?
Uh, hydrogen bond,
Hydrogen bonding. Then
van der Waals,
van der Waals, and then
and dipole.
dipole, and then
That's it.
okay. What is the difference between dipole and van der Waals? Let me ask to T-cell. Hello, T-cell.
Teacher,
Yes. What is the difference between van der Waals and dipole?
Um, dipole force is when the positive side of a polar molecule attracts the negative side.
Yes. And van der Waals.
It's a general term for the attraction of intermolecular forces.
So we can say that uh, hydrogen bonding is van der Waals, but van der Waals is not hydrogen bonding. Or hydrogen or dipole is van der Waals, but van der Waals is not dipole only. Can we say like that?
I don't know, teacher.
Okay. Let me ask to Natasha. Hello, Natasha.
Yes, teacher.
Yeah. What is the difference between intermolecular forces and intramolecular forces?
Intermolecular forces is the force of attraction between the atoms,
Yes.
but intermolecular forces is within the atom.
Okay. So Intramolecular forces is between the atoms, but intermolecular forces between molecules. Okay, and now let's go back to van der Waals and dipole forces. Van der Waals, maybe in other textbook you will see it is called van der Waals, and also there is London dispersion forces. I'm sure that you have ever read in through Google about intermolecular forces. They also write about London dispersion forces. How many of you have ever seen the text written London dispersion forces? How many of you ever read from different source of textbook regarding intermolecular forces?
Not yet. I shall start doing that later on.
Okay, Nathan V is going to start reading about intermolecular forces. Okay.
Great.
Okay. In this online class, it's quite difficult. It's impossible for us to have face-to-face session, and it's difficult for you to reach to ask me directly. Even like example yesterday, there was a comment on the Google Classroom, but I could not open it on time. Okay, so it's quite difficult. You have to help yourself also to read from different textbook. It is not a problem. All the concept of chemistry will be same. They have different terms. One term, different terms, but they will have the same meaning. So example like iodine crystal. Iodine crystal, the formula is I2. Am I right? Felicia, iodine crystal is I2. Is it?
Gas crystal.
Yeah. Is iodine volatile or not? Felicia.
Oh no, it exists as solid.
It is solid. Does it have low melting and boiling point? Or does it have high?
I think pretty high.
Oh, it's pretty high. Okay. If we see, if we read from different textbook, iodine could have London dispersion forces. There is an instantaneous dipole forces. What is the difference between instantaneous? Instantaneous is, or in other textbook, also called dipole induced dipole forces. Okay, meaning that this dipole, before I continue to definition of dipole, what is the meaning of before I continue with concept of instantaneous dipole, what is the meaning of dipole to you? Let me ask to Bhavia.
It means that it has a positive and a negative pole.
Yeah, it has positive and negative pole. So it is in one molecule. Imagine one molecule. There is a left end and right end. Right? It's like so molecule is like a stick. Like a stick, Stick has like a matchstick. Matchstick, there is an end, one end, and there is the other end. The end of the molecule are called as dipoles. So instantaneous dipole means they do not have any positive or negative. Why? Because they are sharing electrons and they have the same electronegativity. But they can have instant dipole, meaning suddenly it becomes positive and suddenly the other end become negative. What makes it like that? Because of the interaction with other molecule, which is different molecule or can be the same molecule. Okay, example like bromine dissolve, or example like iodine. Iodine dissolve in organic solvent. The organic solvent can dissolve iodine. Why is it like that? Because there is an interaction. Although both of them are considered to be nonpolar, there is an instantaneous dipole that makes them able to react, able to combine. But this combination, if we take for longer period of time, the dipole can be broken, and then they go back to their original state. But permanent dipole forces will be different. Permanent dipole forces, they would have the positive and negative forever. But the difference with hydrogen bonding, permanent dipole, the positive and negative or the electronegativity difference is not huge, is not big compared to hydrogen bonding and compared to ionic bonding. Ionic bonding has the huge difference in electronegativity. Permanent dipole is the weak, but they have permanent positive and negative. While hydrogen bonding, it has medium. Hydrogen bonding is the easiest. Why is it the easiest? Because hydrogen bonding only occurs to hydrogen that is bonded to very electronegative element such as nitrogen, oxygen, and fluorine. So all these three. How about the others? Like chlorine. Chlorine is electronegative but not the most electronegative compared to F, O, and N. Okay. And then we know that how about if we compare between oxygen and fluorine? Which one is more electronegative? Of course, it is fluorine. How come fluorine? Because we learn in the periodic table across the period from left to the right, the electronegativity increases. Okay, and then how about if we compare between nitrogen and oxygen, which one is more electronegative? We have to see the number of